Advanced course, episode 6. You have built great AI features. Now let's turn them into products that make real money. Multi-tenancy, API keys, usage-based billing with Stripe, token bucket rate limiting, and streaming responses. This is the business layer. Let's build it. Welcome to episode 6. There is a gap between a cool AI demo and a product that earns revenue. That gap is entirely infrastructure. Auth, multi-tenancy, usage tracking, billing, rate limiting, and the streaming that makes AI feel fast to users. None of these are glamorous. All of them are required. Today we walk through each layer with real code, so you can wrap any AI feature you have already built into a product that is ready for real customers. Multi-tenancy means your system serves multiple customers with complete data isolation. Every API request belongs to a specific user or organization. Their conversation history, their documents, their usage, and their billing are all separate. One user's data never touches another user's context. The foundation of multi-tenancy is your API key system. When a user signs up, you generate them a unique API key. Every request to your backend includes that key in the authorization header. Your server validates the key, identifies the user, and attaches their context to the request. All subsequent operations in that request run in the context of that specific user. Generating API keys correctly matters. Use cryptographically secure random bytes, at least 32 bytes, encoded as hex or base 64 URL, giving you keys of 64 characters or more. Never store the key in plain text. Hash it with SHA-256 before storing in the database. When validating, hash the incoming key and compare to the stored hash. This means even if your database is compromised, no keys are exposed. Store a prefix of the key, the first 8 characters, in plain text alongside the hash. This lets you show the user which key is which, SKRBC12345, without storing the full secret. Let users name their keys, set expiration dates, and rotate them without losing their account data. Now, usage tracking. Every LLM call has a real cost, and you need to know exactly how many tokens each user consumed on which model at what time. Track this at the request level. When you call OpenAI, the response object includes a usage dictionary with prompt tokens, completion tokens, and total tokens. After every successful LLM call, insert a record to your usage logs table with the user ID, the timestamp, the model name, prompt tokens, completion tokens, and total tokens. This table becomes your source of truth for billing, debugging, and cost analysis. For billing, Stripe Meter is the cleanest solution for usage-based pricing. The flow is every time you log a usage event to your database, also report it to Stripe with a single API call. Pass the user's Stripe customer ID, the usage metric name, tokens consumed, API calls made, whatever your billing unit is, the quantity, and a timestamp. Stripe aggregates these events and applies your pricing at the end of the billing period. The customer gets charged automatically. This is genuinely about 20 lines of code once you have your Stripe products configured. The hard part is the configuration, not the code. Rate limiting protects you from 2 very different problems. First, one heavy user can consume your entire API budget in an hour. Second, a bad actor can deliberately run up your bill or degrade service for other users. The right algorithm for AI rate limiting is the token bucket. Each user gets a virtual bucket with a maximum capacity, say 100,000 tokens per hour. The bucket refills at a constant rate. Each LLM call drains the bucket by the actual tokens consumed. If the bucket is empty when a request arrives, you return a 429. Too many request response. Store the bucket state in Redis so it works correctly across multiple server instances. The token bucket is better than simple request rate limiting for AI because it accounts for the actual resource consumption. A user who sends 10,000 token requests should hit their limit at the same point as a user who sends 1,000 token requests. Here is the FastAPI application structure for a production AI SaaS. Your main application registers 3 routers: Auth for API key management and user accounts, AI for all AI endpoints, and billing for usage reporting and payment management. The auth dependency is a function that runs before every protected endpoint. It reads the authorization header, extracts the API key, hashes it, queries the database for a matching key, retrieves the associated user, and checks that the user has an active subscription. If any step fails, it raises an HTTP 401 exception. If everything passes, it returns the user object. You declare this dependency in any route you want to protect. The main AI endpoint is an async function that takes the user from the auth dependency and the request payload. It runs your rate limit check against Redis. If the user has capacity, it proceeds. It calls your LLM or RAG pipeline. It logs the usage to your database and records it in Stripe. It returns a streaming response. Streaming is important for user experience. When your LLM is generating a 500-word response, streaming delivers each token as it is generated. The user sees text appearing in real time instead of staring at a loading spinner for 5 seconds. The perceived quality of your product improves dramatically with streaming, even if the total response time is identical. For OpenAI streaming with FastAPI, create an async generator function that calls the OpenAI API with stream equals true. Iterate over the chunks in the response. Each chunk has a delta with the new content. Yield each chunk as a server sent event string. Return a streaming response, wrapping this generator with the media type set to text event stream. Your front end reads these server sent events and appends each chunk to the display as it arrives. Your challenge: take any AI feature you have already built, a chatbot, a summarizer, a classifier, anything, and wrap it in this architecture. Add API key authentication. Add usage logging after every LLM call. Add a Redis rate limiter that enforces a per user token quota. You do not need Stripe yet. Auth plus logging plus rate limiting is already a production ready API. That is a significant milestone worth hitting this week. One more critical production technique belongs here: semantic caching. Regular caching stores responses keyed by the exact query string. If 2 users ask identical questions word for word, the second gets the cached response. Useful, but rare. Semantic caching stores responses keyed by the meaning of the query. When a new request arrives, you embed it, search your cache by vector similarity, and if you find a semantically similar previous query above a threshold like 0.95 cosine similarity, you return the cached response immediately without calling the LLM at all. No tokens consumed, no API cost, sub-millisecond response time. In practice, users ask the same questions in many different ways. What is the refund policy, and how do I get a refund, and can I return my purchase? Are semantically identical for most support applications. Without semantic caching, you call the LLM 3 times. With it, you call it once. GPT cache is the standard library for this. You initialize it with your embedding function and a cache backend. Redis for production, SQLite for development. You wrap your OpenAI client call with GPT cache, and it handles hit-miss logic automatically. Cache hit rates of 30 to 60% are typical for support and Q&A applications. That is 30 to 60% of your API costs eliminated with one library. For multi-provider resilience and routing, use Light LLM. Light LLM wraps 100 plus LLM providers: OpenAI, Anthropic, Google, Mistral, Grok, your self-hosted Ollama instance under one unified OpenAI compatible interface. You call litlm.completion with a model string like Anthropic Claude Opus 4 or Grok Llama 3 70B 8192, and LiteLLM routes retries and handles provider-specific API differences for you. Configure LiteLLM router with primary and fallback models. If OpenAI is down or rate limited, requests automatically fall back to Anthropic or Grok. Set cost limits per provider. Set latency-based routing. If one provider is consistently slower, route away from it automatically. Your application becomes resilient to single provider outages without changing any code beyond the router configuration. Multi-tenancy, billing, rate limiting, streaming, semantic caching, multi-provider routing. You now know exactly how to turn an AI feature into a real product that stays up, stays cheap, and stays profitable. Episode 7, Self-Hosted AI. Zero API costs, complete privacy, runs on hardware you already own. See you there.